Hey, chemistry, it's me, your teacher, Mr. Harris. In this video, we're going to learn a little bit about plate tectonics. Let's all say it together. Plate tectonics. Good. Now in front of you, you should have a blank piece of notebook paper. At the top of the page, write the date, whatever today's date is, and then underneath that write plate tectonics. Pause the video to do that if you have to. Alright, moving on. So plate tectonics are about the Earth's layers. You should copy down the Earth's layers. So you've got the Earth's crust, which is the whole thing, the rocky crust, then under that you've got the outer mantle, then under that you've got the inner mantle, and then these lines here are like the edges of the plates that we're going to learn about in a minute. So the Earth's rocky crust is about 1 billion years old, and it's not a solid shell. It's not like an eggshell. It's like broken up into big chunks that float around. All right, so write that down. Pause the video to do so. All right, so we're going to talk about the crust, which is the top layer. The top layer, the crust itself, has some layers. It's about 5 to 100 kilometers thick, so that's like 2 to 60 miles thick. It's made of oxygen, silicon, and aluminum, so just basically what the Earth is. Like all the Earth that you see is those elements. It's a lot. I didn't realize it was so much aluminum. All right. Moving on. Then underneath the crust, we have the mantle. The mantle is the layer of Earth between the crust and the core. That's where most of the mass of the Earth is. Most of the mass, the weight of the Earth. So the crust is mostly magnesium, has less aluminum and silicon than the crust. The mantle, has mostly magnesium. It's a lot denser than the crust. So you got the crust, then underneath that you've got the mantle. And as you can see, the mantle has different layers itself. It's got the upper mantle, the rigid part, then underneath that the flowing part, a asthenosphere, then the lower mantle, which is like semi-rigid. Cool. Moving on. Then, below the mantle and in the middle of the Earth is the core. Alright, so they can just guess what the core is like because it's really hard to access, but it's believed to be mostly iron, nickel, not really any oxygen, silicon, aluminum, or magnesium. So write down what the core is made of. The core of the Earth. It's kind of like the... I don't know, I keep thinking of a gobstopper as I'm doing this. It's kind of like a gobstopper. I don't know what the core would be in the gobstopper, like the part that you can finally bite through, except it's made out of iron and nickel. Alright, now tectonic plates. Look at this. We have a map of the world here. But this map of the world shows not only the continents, you got like North America, South America, Africa, Europe, and Asia. But it's also got the plates, and the plates are the things that the continents sit on. Alright, so what plate are we on? Pause this video, figure out what plate we are on. Just write that down. And after that, write down what plate Europe is on. What plate is Europe on? Oh, for God's sakes. Where's my PowerPoint? Moving on. All right. Tectonic plates. And we've got this. All right. So these are some notes about plate tectonics. Copy these down. Copy down these notes, right? Plate tectonics, and copy the notes down. So what they do is they float on top of the mantle, similar to ice cubes in a bowl of water. All right, then we've got this crazy thing called continental drift. So the continents sit on plates, and the plates kind of float around. So as a result, the continents of the Earth are not always in the same place. I mean, they will be in your lifetime, but over geologic time, the continents move quite a bit. So look at this GIF. Shows all the continents moving around. Oh my God, where's America? Wait, is that it? Oh, it's the blue part right there. Oh, but wait, it's over here now. America just kind of cruises around. Amazing, over 800 million years. All right, so the first continent was called Pangaea. Here it is, Pangaea. So in the beginning, all of the continents were stuck together. You guys probably know this already. So you got South America stuck into Africa like that, then Antarctica, Australia. Well, where's North America? It's not on here. In any case, what this slide really shows, though, is how there's archaeological evidence showing that animals lived on different continents. So this guy here, freshwater reptile Mesosaurus, used to live in South America, but they found fossils of him in South America and Africa, but those places are so far away from each other now, which suggests that at one point they were stuck together. Look at this guy. Listosaurus. He lived in India, Antarctica, Africa. What was that, Madagascar? Guy was all over the place. Those places are so far away from each other now. Alright, this is about the seafloor spreading. The plates move. Seafloor gets bigger and smaller. So as of right now, the Atlantic Ocean is actually getting wider right now. And the Pacific Ocean is actually getting smaller. Isn't that crazy? So that's how the seafloor spreads. Not super important right here. Whatever. All right, and this just kind of shows how plates move. See, we got, this would be like a plate here and a plate there, and then like all the pressure from underneath in the mantle kind of makes things swirl around. So a plate that's over here and a plate that's over there will separate from each other. And there's different types of boundaries, plates. You don't really have to write this down. Here's some plates, like right there, and that cuts off Africa from Arabia. This guy's going this way. This guy's going that way. Freaking look at Iceland, man. It's got its own fault line, or it's on like two different plates. North American plate and the Eurasian plate. So what do you think life is like in a place that's on many different plates? That'd be crazy. Yeah, blah, blah, blah. Look, this is cool. The Indian plate and the Eurasian plate. They're knocking into each other right here. Does anybody know what this is right there? It's a mountain range. Why would there be a mountain range there? Moving on. Not important, not important, not important. Oh, this is kind of cool. San Andreas Fault. So look, California's got all these earthquakes, right? You know why? Because that's where some plates are knocking into each other. The plates will like rub on each other. And that is what causes earthquakes. Alright. I would like you to answer questions 1, 2, 3, and 4. For homework, I'm going to give you an open note quiz tomorrow. It's going to be great. Alright, talk to you later.